Time for a little info about the antenna here. So configured for 40 meters, so that's 19.375 meters of wire in my case. The SWR you can see on 40 there, centered on 7.1. It's a little bit low, but it's perfectly usable throughout the band. Less than 2 to 1. The overall plot over 50 megahertz is the picture on the right there. and you can see there's several dips starting 7 megahertz, 14 megahertz, 21 megahertz, etc. There's a few different shots of the SWR expanded out a little bit. You can find, for example, you can see 25 megs plus or minus 5 megs, so that's a 10 meg sweep on the screen. There's a couple of good dips, one of them being 27 megahertz. You can see generally throughout everywhere nothing is worse than 2 to 1 on the SWR, so that's really good. Obviously the closer to 1 to 1 you get, the better things are going to be, so it's nice to see that you've got some nulls, is null's the right word, some better SWRs on certain spot frequencies, but for sure it's usable just about everywhere. This was the old wire I took down from my fan dipole, which went up in March 2020, would it be? The first part of COVID. Was it March 2021? I forget. It's been so long. But anyway, when COVID started, it was kind of start to become a hot issue, sort of January, February. In March everything was short supply. I used some old yellow wire that I had on a spool, and green wire as well, as you can see there, one for each band for 20 and 40 dipole. I used plant markers as spacers or spreaders. These came from the dollar store. You did what you had to do in those times, because you just couldn't get anything in terms of supplies. So I was very fortunate I already had the coax. It's just a case of knocking the rest up. But as you can see, there's some cracks in the wire where the insulation has broken down. That's 2 full years of being in the sky, extreme hot to extreme cold, I guess does that. But when I brought the antenna down, it was probably about minus 15 C, and I think that might have something to do with it. It might have suffered a little bit of wind chill whilst it was there, and me moving it around kind of just made it crack. So this is the new wire I'm using. I got this from Amazon actually. It says everything there, 20 gauge, silicon covered. Interesting to know that the temperature rating on this is minus 60 to 200 degrees C. So that's certainly good for here, because we average, I think, about minus 15 in the winter. The worst I've seen it here is minus 41. That's actual air temperature, not wind chill factor. But generally the air temperature is about minus 12, minus 15. So just for scale, you can see the ring crimps that I have there. The wire is really nice. It's silicon, whether it's silicon coated or it's actually silicon, I don't know. But it's very, very flexible and not at all plasticky brittle like the yellow green that I just showed you. So this was outside. I'd mentioned, I think, in another video that you can't get the wing nuts off of this 49 to 1 transformer. So what I do is I separate the two washers on the thread there. I nick a little piece out of the corner of the crimp, put it over the bolt between the washers, and then pinch it up slightly and then do the wing nut up. That's the best contact. it's soldered in and heat shrunk up just for a little bit of extra protection against the weather. So in Easy Neck, or ESNEC as I call it, I don't really know what it is, I guess it's Easy Neck because it's a stateside thing. Modelled the end fed, and I've also found that if you just run this end fed straight out with no form of counterpoise, the SWR is generally higher. It still does have its notches, but the overall average is higher. So for sure you need a counterpoise against this, and I'm not sure if counterpoise is the right word, but it's wire number 1 in the picture there in green, and in my case it's just a vertical drop of 2 meters. So to match this for 40 meter use, which gives us the other bands as well, the long wire going out, wire number 3, is 19.375 meters. The wire that hangs down from the 49:1 transformer is exactly 2 meters in this instance. I did a lot of playing around in Easy Neck, adjusting this length for the minimum SWR, and what I found for 40 meters is a 2 meter drop was perfect. So you can see lots of information on this software on the screen there. It generally gives you everything we're doing. I have a wire dropping down is wire number 1. Wire number 2 is a short piece which I show as having a source in the middle, so that's our feed point with the coax, and wire number 3 is the long wire that goes out across the garden to the fence. So the actual SWR plot here, this is shown with an impedance of 2,450 ohms. So if you work that out, that's 50 ohms multiplied by 49, hence 49:1. And it shows a low SWR there at 7.2 megs to start with. It's actually the full band, it's what I showed on the Rig Expert pictures. 14 megs, 21 megs, etc. up the spectrum. The far field plots, the plot on the left is if you were a seagull flying over the top looking straight down. That's what you see, and the wire is stretched out along the y-axis, so pretty much north. So you can see it fires a little bit more east-west than it does north and south, but that on the whole is pretty much omnidirectional. The picture on the right is looking at it from the side view. I've rotated it slightly so that you can see the x and y axis, so the north and the east axis, and the top dark piece is the z axis, so that's where your seagull would have flown over the top. So it just shows it sideways, that it's not really a cloud burner. It's not particularly low in terms of lobes, but it's not a cloud burner either. This view of the antenna shows a wavelength spread across the top, or a half wavelength should I say, because you use a 40 metre antenna. Because this is an end-fed half wave, this length is 20 metres. So there's a half wave and it shows the voltage going up and then coming down at the completion of the antenna. So that's why it's tuned and resonant at 7.2 megs in this instance, or 7.1 megs. So the next little bit is my adaptation of it, because I couldn't fit the full length of that antenna. I could not fit the full length of 19.37 metres from my posts to the garden fence, because the city very kindly chopped the tree down outside that gave me the extra distance. Shame on them. So my wire is actually 15.72 metres to the fence, and then we have a little bit of a dog leg. So here's what it actually looks like now. This is kind of viewed from standing on the ground, looking up slightly. The blue spot is closest to us and has the 2 metre wire dropping down, wire number 1. Wire number 3 is the wire that goes over our heads all the way down the garden to the fence. The blue dot at the beginning of 4 is 1 fence post. The blue dot at the end of 4 is 8 foot away, the next fence post. And then we have a 4 foot drop again on that post. These will be pointed out in a photo shortly. So another thing I forgot to mention is that I don't run just the silicone wire on its own and stretch it out from the feed point down to here. I actually run some utility rope, as it's called. It's from Atwood Rope Manufacturing. It's made in the USA. It's a £110 test line. I got 100 foot of this for $8, some craft fair I think it was, but it's fantastic stuff. And as I say, it's been up for 2 years already. It's not UV deteriorated or anything. It's a really good spec rope for the price. So the antenna comes in from a post at the far end of the garden, higher up, comes into the closest post in the picture there. That's where I have the utility cord looped round, a small screw on the top of the post there, and then it runs to the next post, around some cable ties, and then just drops down. I was expecting to have to trim this back a little bit to increase the resonant frequency, but there really is no need, as we've seen in the plots. So here we are, and the same far field plot. Now this time the picture up at the top on the left is the original waveform shown or superimposed on the antenna wire, and the picture on the right is the new version. And as you can see, where it doglegs, the voltage is still high, but it comes down and in at the end. So it's just really what we're doing is just taking the original antenna and folding it around slightly, and it didn't really have any effect on the far field plot. So the only issue I'm having now is the antenna works perfectly on 40 metres, but on 20 metres, 17 metres, etc. it does work, but it produces some form of TVI on my CCTV again. So I'm going to have another test inserting an un in line, and on the instructions it says that it should be put at more than 30 foot of coax length at your transceiver end. I think it's going to actually have to go up by the 49:1 transformer, because that way it will stop any stray RF coming down the coax at all, rather than filtering it out at the shack end where there's already causing the interference. But we'll do those tests. It's pretty easy to do in the future YouTube. Conclusion is, it's a very nice antenna to use multi-band. In this instance, on configured for 40 metres, I don't get 80 metres obviously, but I get every band higher, and a good low SWR across the whole range for me to use, so it is very usable.
So this video, if you like it, our video, comment down below a thumbs up.
Thanks for watching VA3SII. Bye.